Here we have this x cubed minus 4x function, and this is probably not super obvious how to graph this, all right? So to find all these different properties, we're going to need to use our calculator. So let's go ahead and add a graph to our calculator. We've got x, not squared, x cubed, and then minus 4x, and enter. So there's our graph for our function. Now, we would like to state intervals on which this function is increasing, decreasing, or constant. So that's, of course, we start off moving from left to right, we're moving upward. So we know this is increasing up until this point right here. We need to find that point. Okay? Then it starts decreasing, okay, until right here. We need to find that point as well. And then we're increasing again. So we're going to need these points here. I'm going to go ahead and find those. This maximum point, we'll go Menu, Analyze Graph, and find the maximum. And I'll click to the left of it and click to the right of it. All right, so there is our maximum point. We're also going to need this minimum point. So let's do Menu, Analyze Graph, and Minimum. And click to the left of this minimum point and to the right. And there's that point. Okay. And you know what? In part C of this question, we're going to need the zeros. We might as well go ahead and find those while we're at it. Oh, actually, you know what? It doesn't say calculator only, so we're going to be able to do that by hand. So we'll wait on that. All right, so here is our graph. For intervals on which f is increasing, decreasing, or constant, let's start with our increasing, all right? Increasing. Well, from the left, it starts off increasing, all right? So that's from negative infinity. We're talking about x values here, remember? And then we come up to this point right here, this x value, which is at negative 1.15. Negative 1.15. Okay, so on that interval, it's increasing. Then we're decreasing. Let's go ahead and write that. Decreasing. Okay, and of course that starts at negative 1.15. And then it's decreasing up until this point right here, which is at positive 1.15. Always looking at the x values for these. Right. And then after that, we're increasing again. So we'll go ahead and add another interval to this. Okay, and we go from 1.15 to, and then we're going to the right forever, so to infinity. Okay. Notice that when we're talking about increasing and decreasing intervals, we do not use the union symbol. All right, there of course is nowhere in this graph that's constant, so we don't need to worry about that. All right, for B, we want the relative and absolute extreme values of f. Well, we've got a maximum point right there, and of course it's not the highest point of the whole graph because there's points over here that are higher, but it is higher than all the points around it. So we have a relative maximum, and for this one it is the y value 3.08, and it occurs at x equals negative 1.15. This point down here, we've got a minimum, and it's not the lowest point of the whole graph because we've got lower points over here, so it's just relative minimum. And that minimum is, well, the y value is negative 3.08. And that occurs at the x value 1.15. Okay. So those are our relative maximum and minimum values. If you just want to state the points, you can just say the relative maximum point, of course, is that negative 1.15, comma 3.008. and the relative minimum point is 1.15 comma negative 3.08. All right, so now for C, we would like to find the zeros. And apparently we don't need the calculator for that, so let's go and try it out, okay? To find the zeros, we take our function and we set it equal to 0. And our goal is to solve for x. Well, we'd like to factor it if we can, and there is a common factor here of just x. So we factor the x out, and we get x squared minus 4. Well, x squared minus 4, that should look familiar to you. This is a special form. This factors as, this is called difference of squares. Let's look at that over here. Just as a reminder, difference of squares. Something of the form a squared minus b squared. That's difference of squares, and it factors as a minus b times a plus b. So this is x squared minus 2 squared. So that factors as x minus 2 times x plus 2. All right, so now this breaks up into 3 different things. We get x equals 0, x minus 2 equals 0, and x plus 2 equals 0. And then we can solve for x here. Of course, this first one, there's nothing to do. We get x equals 0. For this one, we get x equals 2. And for this one, we get x equals negative 2. So those are our zeros of our function. And finally, state whether f is even, odd, or neither even nor odd. Now, we can look at the graph, but let's see if we can do it algebraically. This function here, anytime you want to check to see if something is even or odd, you simply plug in negative x and then see what happens. If you plug negative x into this, you get a negative x cubed. So negative x cubed. And then you get minus 4 times negative x. Minus 4 times negative x. Now the goal is to simplify this and see if we get back the original function or if we get back the negative of the original function. And if either one of those is what we get, we know we have some symmetry. A negative raised to an odd power is negative. So this is just negative and then x cubed. Then we have minus 4 times a negative x. So that's plus 4x. Now, this here is not the original function. Okay, the original function is x cubed minus 4x. However, notice that we can factor a negative out of this, and we're left with an x cubed minus 4x. And this is the original function. So this gave us negative f of x. And when f of negative x equals negative f of x, that is an odd function.